Dear students, in this video lecture, we are going to learn problems under first shifting theorem, that is multiplying a function by e to the power at and finding its Laplace transform. So first of all, how to identify that we have to use first shifting theorem. So in the question, if you see here, they are asking us to find Laplace transform of e to the power negative 2t sine 2t. So now whenever you have the Laplace transform of product of two functions, then you have to apply the theorems on Laplace transform. In particular, when the product has one of the term as e to the power negative at or e to the power at, then we have to use the first shifting theorem. In our previous video lecture, we derived the first shifting theorem. The first shifting theorem says that if we have a product of two functions and one of the function is exponential, then the Laplace transform of that product will be equal to, we have to find a Laplace transform of the other function and replace s by s plus a or s minus a accordingly in the given question. So now if you see here, we have e to the power negative 2t. So we will be using the first shifting theorem here, which is given by Laplace transform of, because we are having negative 2t over here, we are using e to the power negative at f of t, which is equal to, we have to first find the Laplace transform of f of t and replace s by s plus a. Because we have minus a here, we should replace it by s plus a. So this is the first shifting theorem. So let us apply this theorem for this problem. So in the given question, we have to find the Laplace transform of e to the power negative 2t sine 2t. So at the place of f of t, what do we have here? We have sine 2t. So this is f of t. So applying the first shifting theorem, this will be equal to, we have to find the Laplace transform of, what is f of t over here? Sine 2t, where we have to shift s to s plus a. What is a over here? It is 2. So s plus 2. So first let us find L of s sine t. So what is L of sine t? By the formula we know that Laplace transform of sine at is equal to a divided by s square plus a square. So this result we have derived previously. Now we are going to use this result over here. So at the place of a, here what do we have? We have 2. So this will be 2 divided by s square plus 2 square. And in this we have to replace s by s plus 2. And so this will be equal to 2 divided by, now s has to be replaced to s plus 2. So it will be s plus 2 the whole square plus 2 square is 4. So this is the answer. So therefore the Laplace transform of e to the power negative 2t sine 2t is equal to 2 divided by s plus 2 the whole square plus 4. So this is the solution. Now here we have problem number 2, where we have to find the Laplace transform of e to the power negative t cos 2t. So when we see, we have to find the Laplace transform of product of two functions, where one of the function is e to the power negative t. So we understand that we have to apply the first shifting theorem over here. So what does the first shifting theorem say? So let us write that now. L of e to the power negative at f of t is equal to L of f of t, where s has to be replaced by s plus a. So here if you see in the question, we have to find L of e to the power negative t. F of t is cos 2t. So we see that f of t is equal to cos 2t. So this will be equal to L of, what is f of t? F of t is cos 2t. So first we have to find L of cos 2t, in which we have to replace s by s plus a. What is a? So if you compare these two, the value of a is the coefficient of t irrespective of the sign. So the value of a is equal to 1. So the coefficient of t over here is 1. So s plus 1. Now in order to find L of cos 2t, we should know the formula for L of cos at, which is equal to s divided by s square plus a square. We have previously derived this result, so we will be making use of it now. So therefore, applying this, we get L of e to the power negative t cos 2t to be equal to. Now what is L of cos 2t? Here the value of a is equal to 2. So it will be s divided by s square plus a is 2. So 2 square, and in this we have to replace s by s plus 1. So in the next step, let us replace. So after replacing, you better remove the flower brackets. So when we replace it, s should be replaced as s plus 1. So s plus 1 divided by s plus 1 the whole square plus 2 square is 4. So this is the required solution. Now we shall see problem 3. So now here we have problem 3, where we have to find Laplace transform of e to the power 2t sine 3t. So we see that we have to find the Laplace transform of product of two functions, where one of the function is exponential, and we have to check whether this is e power at or e power minus at. So if you see here, it is e power 2t, so which is the power is positive. So we have to apply the corollary of the first shifting theorem. So what is that? That is Laplace transform of e to the power at, and then f of t is equal to, we have to find the Laplace transform of f of t, and in that we have to replace s by, now here we have plus a, so it should be replaced by s minus a. So always remember, when we have e to the power minus at, we have to replace s by s plus a, and whenever we have e to the power at, that is plus at, then we have to replace it by s should be replaced by s minus a. So we should remember this. Now because here we have positive, we are using this shifting theorem. So let us apply it. So Laplace transform of e to the power 2t sine 3t is what we have to find. So when we compare, we see that f of t is what? Sine 3t. So this will be equal to Laplace transform of sine 3t, and after finding that, we have to replace s by s minus a. So minus, what is a? The value of a here is 2. So s minus 2. First let us find this, for which we will have to use Laplace transform of sine at formula, which is given by a divided by s square plus a square. So when we apply this result, what do we get? We get this to be equal to, further this will be equal to, now Laplace transform of sine 3t. So here we have sine at, here we have sine 3t. So what is a? A is 3. So when we apply this formula, it will become 3 divided by s square plus 3 square. Between the limits, not between the limits, we have to replace s by s minus 2. So now this will be, further we can apply the first shifting property. So 3 divided by, instead of s, we should replace it by s minus 2. So after replacing, you better remove the flower brackets. So s minus 2 the whole square plus, what is 3 square? It is 9. So this is the solution. So this is the solution of problem 3. Hope you have understood this. Next we shall solve problem 4. So now here we have problem 4, where we have to find the Laplace transform of e to the power minus t sine 2t. First we have to apply the first shifting theorem. That is here we have to find the Laplace transform of product of two functions, where one of the function is exponential and that exponential function is e to the power negative at. So we should use this shifting property, that is Laplace transform of e to the power negative at f of t is equal to, we have to find L of f of t first, and in that we have to replace s by s plus a, because we have minus a here, it should be replaced by s plus a. So the shifting is from s to s plus a. So we have to apply this, for which first let us write Laplace transform of the question, that is e to the power negative t sine 2t. So what do we find here? We see that f of t is equal to sine 2t. So this will be Laplace transform of sine 2t, and we have to replace s by s plus a. What is a over here? The value of a is equal to 1. So s plus 1. We know that the Laplace transform of sine at is equal to a divided by s square plus a square. So applying this further, we get Laplace transform of e to the power negative t sine 2t to be equal to, now here if you compare this sine at and sine 2t, so a is what? 2. So 2 divided by s square plus 2 square, and s has to be replaced by s plus 1, and so this is equal to, now after replacing let us remove the flower brackets, curly braces, and then when we apply this it will be s plus 1 the whole square plus 2 square is 4. So this is the required result. Hope you have understood all the 4 problems. In our next video we will see problem 5, which is to find Laplace transform of e to the power minus 3t multiplied with sine square t. So we have a square term here. So let us see how to solve this problem in our next video. Thank you.